So far in this course, you've learned how to retrieve data from tables and views. This is pretty straightforward if you know the names of the columns and their data types. Sometimes you may have to find the name of a particular field in a table, or get the data type for it, or know what collation is used by a string column. These and many more questions can be answered by querying the SQL Server system catalog and metadata, or by using SSMS. If you don't have access to a graphical tool such as SSMS, you can retrieve the same information that it displays by querying the system catalog and metadata. After all SSMS is doing is simply issuing metadata queries on your behalf and displaying its view of a server or a database. In this module, you will learn how to query system catalog views and functions, how to execute system stored procedures, and how to query dynamic management objects. Let's get started with system catalog views and functions. The SQL Server system catalogs is a set of views that show metadata that describes the objects in an instance of SQL Server. Metadata is data that describes the attributes of objects in a system. You can access the metadata through a variety of mechanisms such as system catalog views, system functions, dynamic management objects, and system stored procedures. In this lesson, you will learn how to write queries that retrieve the system metadata using system catalog views, standard information schema views, and system functions. First, let's see what system catalog views are. Dynamic applications that are not hard-coded to work with a specific set of tables and views must have a mechanism for determining the structure and attributes of the objects in any database to which they connect. And these applications may require information such as the number and names of tables and views in a database, the number of columns in a table or view, together with the name, data type, scale, and precision of each column, the constraints that are defined on a table, the indexes and keys that are defined for a table. SQL Server provides information about the database or server by accessing the metadata through a set of views called system catalog views. You can retrieve data from these views just like you would retrieve data from any user table or view using the standard T-SQL select statements. You can also use joins on these views to retrieve information about various attributes and display only certain columns to form a more complete picture of the system. SQL Server-based applications can access the information in the system catalogs by using the catalog views, and some of these views are filtered to display only user objects, whereas some views include the system objects. Catalog views present metadata in a format that is independent of any catalog table implementation. Therefore, catalog views are not affected by changes in the underlying tables. And these views are the most efficient way to access core server metadata. In the previous versions of SQL Server, the users had to query documented and undocumented system tables and views to gather information about metadata. In the current version, all this information can be found by querying catalog views. In the future releases of SQL Server, Microsoft may change the definition of any system catalog view by adding columns to the end of the column list. So it is recommended to not use the syntax select star from any system catalog view in production code because the number of columns returned might change and then break your application. Now let's take a look at an example. In the first query that you see here, it retrieves a list of user tables and attributes from the system catalog view systables. As you can see, some of the columns, like schema ID, have references to other system tables. You can join these views just like you would join user tables or views to gather more information to get the full picture of the system. And the second query retrieves information about both system and user objects. The difference between these two queries is that the first query excludes the system objects. Let's execute these queries and see what the results will look like. Let's open a new query. Let's paste the queries that we just saw and click on Execute. As you can see, the first query retrieved information about just the user objects, whereas the second query retrieved information about both system tables as well as user tables. You can add the order by clause to display the results in a certain order. Let's order by type, description. Let's select this query and click on Execute. And as you can see, the result set is ordered by the description type. Now let's see how to join these system catalog views. Let's join the SysTables to the schemas view on t.schemaid equals s.schemaid, and let's say t.schemaid, and now let's display the schema name. Let's select this query and click on Execute. And as you can see, the corresponding schema names are displayed in the results set. So, now that we have learned about system catalog views, let's learn about information schema views. Information schema views are based on catalog view definitions in the ISO standard. They present the catalog information in a format that is independent of any catalog table implementation. Like system catalog views, information schema views can also be queried to return system metadata. When you want to decide which views to use between SQL Server specific system catalog views and information schema views, you need to know that information schema views are stored in their own schema called information schema, and system catalog views are stored in the sys schema. And they return system metadata per ISO standard, and this data can be used by third-party tools. Information schemas use standard terminology instead of SQL Server terms. For example, they use catalog instead of database and domain instead of user-defined data type. So you may have to adjust your queries accordingly. And like querying any other system view, you can use the select clause to retrieve information from the information schema views as well. Let's take a look at some examples. In this query, it retrieves information from the information schema tables. And this query retrieves the column usage information from the information schema view column usage view. Let's execute these queries and see what the results will look like. Let's open a new query and paste the queries that we just saw and click on Execute. And as you can see, the first query retrieved the information about all the tables that are in the T-SQL 2012 database, and the second query retrieved information about each column in the T-SQL 2012 database that is used in a view definition. You can use joins and order by clauses just like you would use with any other tables or views. Now let's see what system metadata functions are. Transact SQL defines system stored procedures and system functions that return catalog information in addition to views. Although these stored procedures and functions are specific to SQL Server, they insulate users from the structure of the underlying system catalog tables. These metadata functions include scalar functions and table-valued functions that can return information about system sessions and settings, etc. All metadata functions are non-deterministic, which means that these functions do not always return the same results every time they are called, even with the same set of input values. The system metadata functions come in a variety of formats. Some of them are similar to the standard scalar function, like the error number, whereas others use special prefixes like the dollar symbol or the @ prefix. Some of these metadata functions are object ID, which returns the object ID of a database object, object name, which returns the name corresponding to an object ID, the error function, which returns 0 if the last statement succeeded, and the server property function, which returns the value of the specified server property. You can use the setup clause to query a system metadata function. You can use the function in the where clause or in the select clause. Let's execute the queries that you see here and see what the results will look like. Let's open a new query, paste the queries that we just saw, and click on Execute. As you can see, the first query returned the SQL version, the second query returned the product version, and the third query returned the collation information. The server property function accepts many input values like product version, edition, collation, etc. Now let's see how to use the object ID and object name functions. Let's do a simple select of object ID of hr.employees table. Let's select this query and click on Execute, and it will return the object ID for the HR employees table. Let's copy this value and let's do a select object name of this particular object ID. Let's select this query and click on Execute, and it displays the name of the object ID that we just passed. Let's see if we can get the schema name of this object ID. Let's paste the ID here. Let's select this query and click on Execute. And as you can see, it returned the schema of the HR employees table. So, in this lesson, we've learned how to retrieve metadata information from system catalog views, information schema views, and system metadata functions. In the next lesson, let's learn how to retrieve the same information from system stored procedures.